though possibly in a different order. So, today we're getting into section 8.1, which starts on page 4. This chapter focuses in on similar polygons, on similar shapes. In Geometry Standards A, we talked about congruent shapes. And for shapes to be congruent, that meant they were the exact same shape and the exact same size. Similar is a little bit different. Shapes are similar if they're the exact same shape, but they don't have to be the same size. One can be an expanded or a shrunk down version of the other, as long as the shape is the exact same. Now, in order to make the shape the exact same, the angles that match up, the corresponding angles, have to be congruent. In other words, they have to be the same. On the other hand, the corresponding side lengths, the matched up sides, do not have to be the same length. They have to be proportional. So they have to make a proportion, which is a fraction equal to a fraction. Or if there's many sides, it's a lot of fractions equal to one another. It's what we call an extended proportion. Now, when it comes to similarity, first off, that little squiggle, that means similar. It's similar, it's kind of like the congruent symbol, but it's just the squiggle, no equal sign. Equal sign implies congruent. If A, B, C, D is similar to F, G, H, I, those can be similar if and only if all of the angles are congruent and the sides are proportional. Now, one of the things you may or may not remember from when we did chapter 5 is that when you're talking about two shapes with their corresponding parts, their names have to go in the same order. So if A is first and F is first, that means A and F have to be congruent angles. To mark angles as congruent, we put those little arcs inside the corners, inside the angle, with the same number of arcs in each corner. And then to say they're congruent in symbols, angle symbol, its name, congruent to angle symbol, its name. Angle B, that's this one. I'm going to do a double arc. Has to be congruent to angle G because those are both the second letters in the shape. The third letters were C and H, so I'll put the triple mark there. Which ones are single marked, which ones are double marked, which ones are triple marked doesn't have to match up with the name. It just has to make sure the letters match up. Meaning I could have done angle C and angle H as single angle marks as long as F and A were triple angle marks. Angle C is congruent to angle H. And the last one is angle D has to be congruent to angle I. 1, 2, 3, 4. 1, 2, 3, 4. So corresponding angles are congruent. Now for the corresponding sides. The corresponding sides are going to be stuck between the same corresponding angles. They also can use the names to their advantage. For Chapter 8, starting today, one of the things you might want is some highlighters. generally a couple of highlighters. I would take 3 different color highlighters. If you don't have your own, I'll come around with these ones. Do you have highlighters? You can do 3. Sometimes we'll only use 2, but you can use up to 3. Just make sure my highlighters go back in the box. 3 different colors. Can you need highlighters? 3 different colors. Starting tomorrow, I'm just gonna have you grab them as you come in. Three different colors. You do need to learn how to count to 3. I have a feeling most people know how to do that.
Yeah.
I question you more than Trey.
Why?
Interesting.
I actually do it.
So does Trey.
I used to have class with me.
Okay. Now when it comes to the corresponding sides, you can recognize corresponding sides a couple of different ways. First off, between what angles are they marked? If it's between the single and the quadruple angle, on the other shape between the single and the quadruple angle. So AD corresponds with FI. The other thing you can look at is the letters in the name. A and D are the first and the last letter, so it has to correspond with F and I, the first and the last letter. One of the things that's nice in this chapter, and for this particular part, it might not be as necessary, but it's helpful to highlight corresponding parts. Now note I only had you pick up 3 highlighters, and this is a 4-sided shape, mainly for a couple reasons. One, generally speaking, most of the time we're going to have triangles. Also, can you assume that if you've got 3 different corresponding pairs highlighted, that the one that's not highlighted matches with the one that's not highlighted? Generally, that's why I just say go with 3, because especially I run out of highlighters otherwise. Okay, now corresponding sides must be proportional, so I have to be able to make the fractions with them. If I choose any side length to start with, it doesn't matter which side I start with, I'm going to start with this one, AB. That sets up how my extended proportion needs to go. This extended proportion is known as a statement of proportionality. And I put AB over the top of its corresponding side. AB's corresponding side is FG. And that is equal to. Now, I need to make the top of every single fraction that I write out come from the same shape. AB came from this shape, which means the top of all my fractions need to come from a side off of this shape. My other corresponding sides are BC going with GH equal to. Again, I have to put this shape on top, CD over HI, and the last corresponding side is AD over FI. Oops, I didn't mean to write side, I meant to write shape. statement of proportionality makes a bunch of fractions with all of the corresponding sides, focusing on the same shape being on the top as and the same shape technically is on the bottom. That gives us our statement of proportionality. Now when we work with these similar shapes, where we have the two shapes, which honestly can be the exact same size, but most of the time they're either an enlarged or a reduced version of one another. What you're doing when you've got those proportional sides and you're making them bigger or making them smaller, what you're actually doing is you're taking all of the side lengths and multiplying every single one of them by the exact same number. That number is known as the scale factor. Oftentimes, the scale factor is given by the variable k, and it's a ratio of the lengths of the corresponding sides. It's a fraction for the corresponding sides. It enlarges or reduces the side lengths proportionally. Now, when you're doing a scale factor, the order matters if I'm giving you a situation where I talk about going from this shape to this shape, and we'll talk about that a little bit more shortly. But it's written always as a simplified fraction. It's never written as a decimal. Now, if it is a reduction, if it's taking a shape and making it smaller, that scale factor k is going to be smaller than 1. If it's an enlargement, that scale factor k, or sorry, why did I say larger? That's a smaller, that's a less than symbol. Oh my goodness, Spence, get it together. If it's a reduction, k is smaller, less than 1. If it's an enlargement, k is bigger than 1. That's what causes the things to get bigger or smaller. Multiply by a number smaller than 1, you get smaller numbers. Multiply by a number bigger than 1, you get bigger numbers. Now, in order to make that happen, if it is a reduction, that k has to be smaller than 1. The smaller corresponding side goes on the top of the fraction. Goes in the numerator. If it's an enlargement, if you're getting bigger, the smaller corresponding side will go on the bottom of the fraction. So, if I was going from this shape to this shape, I would be getting smaller. You can visibly see you're getting smaller going from that one to that one. My scale factor would need to be smaller than 1, and I would find that by putting this shape's side lengths on top, because this is the one that's got the smaller ones. If I was going from this shape to this shape, it would be an enlargement to go from little to big. And therefore, I want the small sides, which come from this shape, to be on the bottom of the fraction when I make the fraction. Those two movements, to go from big to small or small to big with the same shape, those scale factors are always going to be the reciprocal of one another. Do y'all remember what a reciprocal is? A flipped fraction. Two-thirds versus 3/2. Those are reciprocals. Okay, next page we start to get some actual practice with the concepts. Okay. In the diagram, triangle RST is similar to triangle XYZ. We want to find the scale factor, list the congruent angles, write a statement of proportionality, and then it asks, is it a reduction or an enlargement? Okay, First thing I recommend you do, recognize your corresponding sides. First two letters in this name are RS. RS should correspond with which side of the other shape? First two letters should go with XY. Now note, they're not always going to be orientated the same direction. Sometimes the shapes get spun around. So you do need to look at the letters, not at where they are in the picture. ST. I'm going to do next. ST goes with YZ. And last but not least, RT then has to go with XZ. So, make sure you know which sides correspond. That's going to be the most important thing. Now, we want to go scale factor going from RST to XYZ. In other words, going from this shape to that shape. Is the shape getting bigger or smaller? Smaller. So we can actually answer 4 right, or D right here. If it's getting smaller, is it a reduction or an enlargement? Reduction. Explain. You could say getting smaller, or
the numbers are smaller.
K will be less than 1. Now, we haven't found the scale factor yet, but it will be less than 1 when we find it. You're right, the numbers are smaller. That's how we could tell it was a reduction. Okay. Now, since it is a reduction, since it is getting smaller, we want the smaller corresponding sides on top of our fraction. So we want sides from this shape going on top. Now when you're trying to find your scale factor, you don't need all 3 sides. You need 1 pair of corresponding sides. I look at the sides and ask myself which numbers look easiest to work with. 15, 18, or 12? Any of those feel more friendly than the others? 15 is a nice number. Think about the fact that you're going to have to divide it by something. Which number do you know what things divide out of it most easily? 15 is probably the one for most people, because if it ends in a 5, you know it divides by a 5. So I'm going to choose the 15. Going to write a little note to myself, smaller on top because it's a reduction. 15 over, what's its corresponding side? 25. I highlighted them both in yellow. Now you must simplify the fraction. What do 15 and 25 both divide by? 5. I get 3/5. That is K. That is my scale factor. Okay, part B says list the corresponding angles. Well, I can go with the names, or now that I have my triangle completely highlighted, I can use the triangle. If I go by the names, angle R is first. It goes with angle X. If I go with the picture, I would look at things like angle S is stuck between the red and the green sides, which means it corresponds with Y, which is between the red and the green sides. Either way, you're matching up the same sides. Angle T is congruent to angle Z. Yes?
So why did we do that on A? What was the plan
What was the point of finding the scale factor?
Yeah, or like, how do you find that exactly?
So you find it by matching up a pair of corresponding sides and dividing them.
Okay.
Since it was going from this shape to this shape, it was getting smaller, so we put smaller side on top.
Yeah.
And now, and we always simplify the fraction. But here's the thing. Here's why we like this. Now, if I were to take any of these side lengths on the bigger one, because I'm going from big to small, if I were to multiply them by 3/5, I would get the side length on the other shape.
Okay.
That's what it gives us, is it gives us the ability to find the other sides. Now we know the other one's sides on this. There will be a point where we don't. Okay, those are the corresponding congruent angles. Now we need the statement of proportionality. The statement of proportionality is the big long proportion with the names. Okay, so I pick a side length to start with. When you're writing a statement of proportionality, it doesn't matter which one you start with. Say I start with RS, or I guess I'm writing SR because I started with SR. SR would go over. SR's green, goes with XY or YX, equals. I need to choose the other side. Do you want to go red or yellow next? Say we go yellow, make sure which shape goes on top now. The big one, because I put the big one on top here. I just have to be consistent. If I'm going to put SR on top, I have to put RT on top and TS on top in my fractions. RT goes with XZ, and TS goes with ZY. Similar problem. Triangle UST is similar to triangle GEF. First off, we're going from GEF to UST. That's going that way. Vivian, is that a reduction or an enlargement? Enlargement. Getting bigger. When it's an enlargement, the smaller corresponding side goes on bottom. For the scale factor, I need to know what matches up with what. I'm going to start with US. Elena, what side of the other shape does US have to match up with? Use the names. US are the first two letters, so it has to go with GE. I'm going to go to TS next. Kylie, which side does TS have to match up with? TS is right here and right here, so it has to match up with FE. Okay, means UT's got to go with FG. Greta, which side length would you like me to put on the top of the fraction? Sure. 26 goes on top. As long as the smaller one goes on bottom, it doesn't matter which one you start with. You just got to make sure that on the other side of the fraction, you're matching up. Cam, if I'm putting 26 on top of the fraction, what has to go on the bottom of it? 13, because that's the corresponding side. 26 and 13 both divide by? Unfortunately, we probably chose the hardest one to do. 13.
Oh.
It's 2 over 1, which you can just write as 2. That's our scale factor. I need corresponding angles. Nate, angle U is congruent to which angle?
G.
Aiden, angle S is congruent to which angle? Which means angle T's gotta be congruent to angle F. They're in the same place in the names. They also are between the same colored sides. Okay. Let's say I choose to put US on top of the statement of proportionality. Trey, if US is going on top, what's going on bottom of it? I'll give you a second. Think about it. Look at the names or look at the pictures. Yes, US goes with EG. Lily, what would you put in another fraction? Over. You got it. Colin, what would you put as our last fraction?
I would put UT
Over.
over FG.
You got it. Now, we're not always going to ask all those questions. Sometimes the questions are going to be much smaller, and they're just going to ask for you to find the scale factor. Now, when it asked to find the scale factor on these ones, it said from this shape to this shape. This one doesn't. This one just says find the scale factor, which means it doesn't care which direction you go in. It just wants you to get one of the two possible scale factors. Either from this shape to this shape, or from this one to this one. Start by recognizing your corresponding sides. Let's say I start with TV. TV goes with which one? QS, first and last letters of the name. Say I go to TU next. TU goes with QR, first and second letters of the name, which means RS with VU. Pick any side length to work with. Which side looks the nicest to work with? Ooh, not 80 and 60. 80 and 50. Okay, pick one to go on top. Let's say I want 80 on top, 50 on bottom. What do 80 and 50 both divide by? 10, they end in a 0. And I get 8 over 5. Had you put it 50 over 80, you would have gotten 5/8. Because the scale factors are reciprocals of one another. You don't have to write this part. I'm doing that for the sake of the people who are not here.
So the way we go, so if it went larger to smaller, would it be 8 over 5 or would it be 5 over 8?
Since we went, so
Which way did we go?
this was the enlargement because this is bigger than 1. What we chose to do for going from 8/5 is we went from triangle TUV to triangle QRS.
Okay.
But you didn't have to.
Yeah. Could have gone either way.
Yep. This one's smaller than 1 because the top of the fraction's smaller than the bottom. That's how you can tell bigger or smaller.
So that would have been, so the second one there would have been bigger to smaller.
Correct.
Okay.
Okay. We're going to do a little bit of the next page, but I know kind of where we are on time. It's a little bit further along than what I'd like to be. Okay, the last thing you're going to see is problems that look like the ones on this page. Let's say the scale factor from this shape to this shape is 3/4. Answer the following. First thing it asks is, what is the scale factor going the other direction? And it is 4/3. Because of the fact that they're reciprocals of one another. Now, in our original scale factor, is 3/4 bigger or smaller than 1? Top is smaller than the bottom, which means it's smaller than 1. So, that means the original one was a reduction. Going from this shape to this shape made it smaller. Which means this is the smaller shape, this is the larger shape. Now, why this is helpful to know is because we have the ability to solve for missing side lengths, provided we know which way this fraction goes. By knowing that this is a reduction, and therefore this is the smaller shape. This shape, its side lengths got put on the top of the fraction. Well, this one got put on the bottom of the fraction. That can be helpful for questions like B and C, which is the last two things we're doing. BD is equal to 12, find WF. First off, BD and WF are corresponding sides. First two letters, first two letters. You can find corresponding sides if you know a scale factor and you know the corresponding one by using the scale factor to make a proportion, to make a fraction equal to a fraction. You set 3/4 equal to a fraction that includes 12, and for WF, we call it X. We just have to make sure that we put the BD on the right side of the fraction, and the X on the right side of the fraction. BD. Which shape did it come from? First one, which means it needs to go on the bottom of the fraction. 12 goes on bottom, X goes on top. How do you solve a proportion? Cross multiply. 3 times 12 equals 4 times X. In other words, 36 equals 4X. Divide, and X is equal to 9. Which is what WF, what we were actually trying to solve for, is. I can do the same thing with any pair of corresponding sides. Just gotta make sure I'm putting things in the right spot. JW does indeed go with KB. My scale factor I'm going to use is the 3/4 because that's the one we talked about, what goes on top, what goes on bottom. KV is what we're solving for, so we're going to put a variable. Does JW go on top or on bottom? JW came from that shape was on top. And you cross multiply to solve. Oops. Sick of my talking yet?
Nope.
Definitely. And nope. I appreciate that. Okay, but we are going to be done right there today. We started 8-1. Our worksheet that I'm giving you today is going to be due Thursday. 8.1 worksheet 1. I promise most days I will not be talking this long.